Look up at the sky. You are standing beneath an invisible ocean weighing billions of tons. Yet paradoxically, our agriculture is dying of thirst right in the middle of it. You breathe it every second. 78% of the atmosphere is nitrogen, the absolute building block of life. But look down at your fields. Why are you opening your wallet to pay for lifeless white granules stamped with corporate logos when the raw material is floating freely right above your head? This is the grandest heist in the history of modern cultivation. We have been programmed to believe that fertility comes only from factories, from high-temperature reactors burning fossil fuels, not from a silent biological engine that existed long before dinosaurs walked the earth. There is a living entity, a green microchip of nature, that once fed the most brilliant rice civilizations of the East for a millennium without a single drop of petroleum or a gram of synthetic urea. It is not magic. It is the pinnacle of symbiotic technology that modern science is only just beginning to fully decode. But then it vanished from the industrial landscape. Not because it stopped working, but because it was too effective. A dangerous form of autonomy for business models built on dependency. They shoved it into the margins of history books, labeled it a weed or a relic, to pave the way for the era of chemical addiction. Today, we are dragging it out of the shadows. We are going to strip away the dust of time to show you just how powerful this forgotten technology truly is. We must rewind the tape of history, past the industrial smoke, back to the 11th century in the Red River Delta. While Europe was still fumbling in the Dark Ages, a sophisticated biotechnology was already being deployed in the rice paddies of Vietnam and southern China. This is not folklore. This is the record of the world's first biological patent. In ancient Vietnamese records, there are mentions of a goddess of Azola, a matriarch who didn't just discover this plant, but standardized its cultivation. But here is the smoking gun. The knowledge of how to multiply this green gold was treated with the severity of a modern state secret. Feudal decrees prohibited the export of the technique outside specific villages. Why would an empire lock down a floating fern? Because they understood the physics of power better than we do. They knew that this plant was an energy multiplier. If you controlled the nitrogen, you controlled the rice yield. If you controlled the surplus, you controlled the armies and the population. For centuries, the propagation of this fern was restricted to elite guilds, passed down through bloodlines like encryption keys. When you see ancient shrines dedicated to this plant, do not mistake it for primitive superstition. Those temples were not just places of worship. They were essentially temperature-controlled laboratories designed to keep the mother cultures alive through harsh winters. They were preserving a proprietary technology that fixed nitrogen from the air 1,000 years before Fritz Haber won a Nobel Prize for doing it with high-pressure steel pipes. We look back at them as simple farmers, yet they were operating a renewable energy grid for their soil, a system we foolishly dismantled in exchange for the convenience of bagged powder. Enter the early 20th century, and the sound of the industrial hammer shattering the natural order. Two German chemists, Fritz Haber and Karl Bosch, did what nature had done silently for eons, but they did it with brute force. They invented a way to rip the triple bond of atmospheric nitrogen apart, using massive pressure and fossil fuels. This was the birth of the Haber-Bosch process, a technological marvel that today consumes nearly 2% of the world's total energy supply. But while it promised to feed the world, it quietly enslaved the farmer. This was the moment humanity pivoted from working with biology to waging war against it using chemistry. The so-called Green Revolution that followed was a Trojan horse. It arrived with the promise of miraculous yields. But those new, high-yielding seeds were genetically engineered to be addicts. They could not perform without heavy doses of synthetic nitrogen. The industrial complex saw the flaw in the Azolla model immediately. It was free. You cannot patent a fern that doubles its own biomass every 3 days. You cannot put a barcode on a self-replicating organism that allows a peasant to bypass the global supply chain. It was a business model nightmare because it offered total liberation. So, the systematic suppression began. Agricultural extension services, funded by petrochemical giants, stopped teaching the art of cultivating this living fertilizer. The narrative shifted. The symbiotic knowledge was labeled primitive and labor-intensive, while the tearing open of a plastic sack was marketed as modern and efficient. We traded a solar-powered, self-regulating biological system for a finite, polluting, and expensive industrial drip feed. Farmers were demoted from managers of complex ecosystems to mere consumers of corporate products, hooked on a cycle of debt and soil degradation that continues to this very day. Fast forward to the present day, where the laboratories are finally validating what the temples knew all along. This is no longer just folklore. It is hard, undeniable data coming from the International Rice Research Institute and cutting-edge agronomy journals published between 2020 and 2023. When global supply chains choked and fertilizer prices skyrocketed, the scientific community scrambled for alternatives, and they found the answer was already floating in the water. The numbers are absolutely staggering. We are talking about a nitrogen-fixing potential of up to 1,100 kilograms of nitrogen per hectare per year under optimal conditions. Let that number sink in for a moment. Compare that figure to your standard leguminous cover crops, beans, peas, clover, which might give you 100 to 200 kilograms if you are lucky. Azolla is not just better. It is in a completely different weight class. It is the heavyweight champion of biological nitrogen fixation. Recent field trials have proven that this fern can sequester carbon and pump nutrition into the soil at rates that make synthetic application look inefficient. The green gold has been peer-reviewed, stress-tested, and validated. The only reason you aren't using it is because the industry hasn't figured out a way to sell it to you in a plastic bag. Zoom in. We are leaving the visible world and entering the microscopic architecture of a marriage arranged 80 million years ago. What you see as a simple floating leaf is actually a complex biological housing unit, a fortress built to harbor a specific guest. This is not just a plant, it is a superorganism. The fern, Azolla, provides the infrastructure, but the engine is a microscopic thread of cyanobacteria known as Anabaena azolae. They are locked in a permanent, hereditary embrace so tight that the bacteria are passed down from generation to generation through the fern's spores, like a biological inheritance. Inside the dorsal lobe of every single Azolla leaf lies a specialized sealed cavity. This is the reactor core. The plant pumps this chamber full of sugars and creates a low oxygen environment, which is the critical physical condition required for the magic to happen. In exchange, the Anabaena activates an enzyme called nitrogenase. This enzyme is the biological equivalent of a heavy industrial cracker. It performs a feat of atomic physics that human factories need 500 degrees Celsius and 200 atmospheres of pressure to achieve. Nitrogen gas is held together by a triple bond, one of the toughest chemical bonds in nature. It is inert, stubborn, and useless to most life. But inside that microscopic leaf cavity, the nitrogenase enzyme snaps that triple bond like a dry twig. It captures the inert gas and protonates it, reassembling the atoms into ammonia, a form of nitrogen that life can actually consume. This is a cold fusion of agriculture, a biological foundry operating at ambient temperature, turning the thin air into solid fertilizer right before your eyes. Now, let's strip away the biology for a moment and look at the pure physics of this machine. We are not talking about simple addition here. We are witnessing a biological algorithm based on exponential functions. In the world of finance, compound interest is considered the eighth wonder of the world. But in your paddy field, Azolla is the physical embodiment of that mathematical power. The critical metric you need to understand is doubling time. While a cornstalk takes months to mature, this fern operates on a frantic clock, duplicating its entire biomass in as little as 2 to 3 days under optimal conditions. Think about the implications of that geometric progression. You start with a handful, and within weeks, you're looking at a green blanket covering the horizon. Scientists and terrified ecosystem managers call it a biomass monster for a reason. It captures solar energy and atmospheric carbon with a ferocity that makes terrestrial plants look lazy. In fact, paleoclimatologists have linked a massive prehistoric cooling event, the Azolla event, to this very plant, calculating that it sequesters carbon up to 8 times more efficiently than a modern tropical rainforest. It is a biological singularity, a runaway reaction of growth that turns sunlight and air into solid matter faster than almost any other multicellular organism on Earth. This is not a miracle. It is the raw, unyielding physics of life operating at maximum efficiency. Now, we move from theory to tactical deployment. You are not just planting a crop. You are initializing a biological reactor, and like any sophisticated machinery, it requires precise calibration before you flip the switch. To activate this nitrogen engine, you must first construct the correct environment. The water must be still, but it must not be dead. Azolla is a floating aquatic fern with delicate hanging roots that act as nutrient probes. Strong currents or turbulent irrigation channels will shatter the colony and disconnect the symbiotic link. You need a shallow water column, ideally 5 to 10 centimeters deep. This specific depth is not arbitrary. It concentrates the nutrients where the roots can access them immediately, turning your paddy or pond into a high-density nutrient broth rather than a diluted ocean. Here is the chemical secret that separates the masters from the amateurs: phosphorus. The industrial dogma teaches you to buy nitrogen, phosphorus, and potassium, N, Pk, together. But remember, this machine pulls nitrogen from the thin air for free. It does not need you to add nitrogen. However, the nitrogenase enzyme, the molecular hammer that breaks the air apart, runs on adenosine triphosphate, ATP, and ATP is built on a backbone of phosphorus. If you starve the water of phosphorus, the engine stalls. You must prime the water with a small strategic dose of rock phosphate or animal manure. You are not fertilizing the plant. You are providing the ignition spark for the atmospheric extraction process to begin. The most lethal error occurs in the first 48 hours. Do not dump your starter culture into a vast open field and expect it to survive. The colony relies on quorum sensing, a density-dependent behavior. If the ferns are too spread out, wind and wave action will tear them apart before they can establish a localized microclimate. You must start in a nursery, a small protected enclosure where you can maintain a pH between 5.5 and 7.0. This is the incubation phase. Only when the biomass has formed a coherent, interlocking mat do you release it into the main arena. Treat this organism with the respect due a living laboratory, and it will reward you. Treat it like common grass, and it will perish before it even begins to work. Once the reaction is sustainable and the surface is sealed with green, you shift roles from architect to reactor technician. This is not a passive system. It is a high-performance biological engine that demands active monitoring of its thermal thresholds. The nitrogenase enzyme the very heart of this operation, is temperature sensitive. It thrives in the mild warmth of 20 to 30 degrees Celsius, but if you let the water overheat in the blistering midsummer sun without shade or circulation, the machinery begins to stutter. You must manage the water level religiously. If the mat gets too thick, the lower layers are suffocated, cut off from the light, and begin to rot, crashing the pH and turning your nutrient factory into a septic tank. You must thin the herd constantly to keep the colony in its rapid growth phase. Then come the looters. The scent of such high-protein biomass is a dinner bell for every snout beetle and moth larva in the ecosystem. But here is the iron rule. Do not reach for the spray gun. The moment you introduce synthetic pesticides, you are nuking the very symbiosis you work to establish. You are fighting biology with chemistry again, and you will lose. Instead, deploy the biological perimeter defense. Ducks and certain fish species are the natural guardians of this technology. They consume the pests while leaving the fern largely intact. They're waste cycling phosphorus back into the water in real time. You are building a food web, not a sterile operating room. Finally, you must learn to read the dashboard of this living machine. The plant communicates its status through a vivid color code. A healthy, nitrogen-pumping colony is a vibrant, electric green. But watch closely. When that green shifts to a bruised purple or a rusty red, the colony is screaming at you. It is a distress signal indicating phosphorus deficiency or thermal stress, a sign that the atmospheric intake valves are closing. This is not a defect. It is a built-in diagnostic feature. Listen to it. Adjust your mineral inputs or water depth immediately, and watch the green engine roar back to life. Now we arrive at the harvest. But you must erase the traditional image of a seasonal reaping from your mind. This is not a crop that has a beginning and an end. This is a continuous flow biological reactor. And if you do not constantly tap the energy, the system will suffocate itself. The mistake most novices make is greed. They wait for the biomass to pile up thick and heavy. But remember the physics of exponential growth we discussed. Growth stops when space runs out. If the mat becomes too dense, the lower layers are starved of light and oxygen, triggering a die-off that crashes the entire colony. You must become a manager of density. You need to perform a rolling harvest, removing 30 to 50% of the biomass every week to keep the colony permanently locked in its aggressive, rapid growth phase. You are essentially keeping the plant hungry for space, forcing it to run its nitrogen-fixing engine at maximum RPM. Once you pull this dripping green gold from the water, you are holding the most versatile biological battery on the planet. You have two tactical options. First, you can deploy it immediately as green manure. Throw it directly onto your soil or around the base of your crops. Unlike straw or wood chips, which rob the soil of nitrogen as they decompose, Azolla has a perfect carbon-to-nitrogen ratio that allows it to melt into the earth, releasing its nitrogen payload in a matter of weeks, not months. It acts as a suffocating mulch that blocks weeds, retains moisture, and then dissolves into pure plant food. It is a self-composting fertilizer that requires no turning, no piles, and no waiting. Your second option is to bypass the soil and feed the protein directly to your livestock. This fern is rich in essential amino acids and can replace a significant portion of expensive, imported soy or fish meal in the diets of ducks, chickens, pigs, and fish. When you feed Azolla to your animals, you are closing the final gap in the circle. The animals eat the plant, they grow faster, and their waste, rich in phosphorus and digested organic matter, goes right back into the pond to fuel the next generation of Azolla. You have just created a zero-waste, closed-loop energy system. You have eliminated the feed store and the fertilizer depot in one stroke. This is the definition of agricultural independence. We have reached the end of the file. But for you, this is the beginning of a much more dangerous realization. We have stripped down the engine of the industrial food system and found it wanting. We have exposed the chemical fertilizer industry for what it truly is, a brute force addiction that turns fossil fuels into food at the cost of your soil's soul. And we have reintroduced you to the silent green sovereign that has been waiting patiently in the murky water for 1,000 years. This was never just about a floating fern. It was about who holds the keys to the kingdom of life. The question now is not whether this technology works. The physics of the nitrogenase enzyme and the exponential growth curves are irrefutable. The question is moral, and it is deeply personal. Are you content to remain a client of the chemical giants, a mere node in a supply chain you do not control, forever swiping your card to fix the fertility you destroyed? Or do you have the courage to step off the treadmill? The industrial complex bets on your laziness. Nature bets on your intelligence. True independence is not gifted, it is cultivated. Every time you scoop a handful of this living fertilizer from your pond, you are cutting a wire that tethers you to the grid. You are declaring that you can generate your own fertility, your own feed, and your own future without asking for permission or checking the market price of urea. The blueprint is in your hands. The spores are waiting. The water is ready. Will you continue to pay for the air you breathe, or will you finally learn to harvest the sky?